Right, we've been dealing with functions. We've been talking about the properties of functions. We've talked about linear and quadratic functions. Now let's look at functions in and of themselves and how we can combine them. Here are a few ways, and these are ways familiar to you. These are just the basic operations that we do on numbers. So for example, we can add functions, subtract them, multiply them, and divide them. And here's how we do that. It's a very natural way of doing that. So if we add two functions f and g at some x, that means take f, evaluate it at x, and add g, evaluate it at x. Subtraction works the same way. F minus g of x, we have f of x minus g of x. Products works naturally, f of x times g of x. And the quotient of two functions, f over g. So f of x over g of x. And here, of course, we can't divide by 0, so we have to include this. We have to make sure that g of x is not 0. The domains of a combination of two functions, f and g, will be, with the exception of this case, will be the intersection of the domains of the two functions. So just those x values that can be plugged into both functions will be included in the domain of a composition. So here we have two functions. We have f of x equals x squared plus 1, and g of x equals the square root of x plus 3. We're going to find f plus g, f minus g, f times g, and f divided by g, and then we'll state the domains for each. All right, let's do that. So f plus g this is going to be f of x plus g of x. And here we have f of x, which is x squared plus 1. And then g of x is the square root of x plus 3. So this is simply x squared plus 1 plus the square root of x plus 3. Now, when I go to evaluate this and plug in the functions for f of x and g of x, I like to put them in parentheses. And I do that because if there is a subtraction or minus sign around, this will make sure that I'm applying the minus sign to every term in the function, if that's necessary. So I encourage you to do that. Okay, let's find the domain of this function. F of x is a polynomial, x squared plus 1. Polynomials have domain all real numbers. This function, square root of x plus 3, is a radical function, and we know we cannot take the even root of a negative number, and since this is a square root, it's an even root, the x plus 3 must be greater than 0. So let's figure out what that is. So x plus 3 must be greater than or equal to 0. Make sure that we can take the square root of 0. Subtract 3, so x must be greater than or equal to negative 3. So we have all real numbers from f. G of x is all numbers greater than or equal to 3, and so the domain must be all numbers greater than or equal to negative 3. All right, let's find the difference. So we have f minus g of x. That's going to be f of x minus g of x. So we have our x squared plus 1 minus square root of x plus 3. These are considered grouped. The minus sign here, so we don't have to worry about that. The square root kind of naturally groups the x plus 3 together. All right. The domain of this is also the domain of the sum, so the domain here, negative 3 to infinity. All right. Let's look at the product. So f times g of x, that's going to be x squared plus 1 times the square root of x plus 3. And here again, the domain is negative 3 to infinity. All right, last step is division. So we have f of x over g of x. That's going to be x squared plus 1 divided by the square root of x plus 3. Now here the domain is going to be different. We have to start off with all the numbers that can be plugged into f and g, and then include or exclude any x value that causes the denominator to be 0. So we can see that negative 3 makes the denominator 0. So whereas they're included in all of these domains, we'll have to exclude it for this. So we'll do parentheses, negative 3 to infinity.